Today is Faults of LA, and what that means is that we're going to be covering two big fault lines that run through West LA because I got to run some errands and it's my part of town. It's also kind of cool because these two main faults, the Hollywood Fault and the Santa Monica Fault, they run through most of West LA, and they are directly linked to the Santa Monica Mountains, which run along West Los Angeles as well. And a lot of the time you drive through this area and you're driving over it and you have no idea. So they've shaped and had a lot to do with the geology in the area, but you don't always know about it. So anyway, before we get started, before I talk about the history, I'm gonna cover a couple of basics with the fault lines, with different kinds of faults. So I brought today something to demonstrate. All right, first, basic terminology about the two sides of a fault line. You have something called the hanging wall and you have the footwall. I had been told that these terms were given first by miners. I don't know if that's actually true or not. My geology teacher told me that, and as I'm saying it, I never thought to look up whether or not it was true. But the idea is that as you're walking along a fault, the hanging wall is where you would hang your lantern from, and the footwall is what you would walk along. So you have the fault line running through here. The top of the fault overlying it is the hanging wall. The top below it is the footwall, or the part below it is the footwall. All right. First kind of fault, normal faults. Normal fault, the movement's what we call normal, duh. And what happens is the hanging wall drops and the footwall goes up. If you were then walking along said fault line, you just like encounter this little uplifted part here. So again, hanging wall drops and the footwall rises up in a normal fault. The second kind of fault is what's called a reverse fault. Oh, I should point out normal faults come from what would be called extensional faulting. So when you're pulling things apart, this drops down. All right, then you have what's called a reverse fault. And a reverse fault is the hanging wall moves up and the footwall moves down. That's occurring when you have compression. So you then have the hanging wall overlying and the footwall down below. So if you have two things moving toward each other, the footwall is dropping down while the hanging wall is going up. So, okay, we've got normal fault, bam, reverse fault, this. The third one I don't have a demonstration for because it's the easiest, and that's a transverse fault, or a strike slip fault. It's really what the term I'm probably going to use most. Strike slip is when you have two faults that run against each other side by side, and one goes one direction, one goes the other. If that sounds familiar, that's because we're thinking of the San Andreas Fault, where that's happening. I talked a lot about that during the Salt and Sea video, that one side's moving one direction, one side's moving in the other, but it's parallel motion in a horizontal space. So the other two were vertical motions. This is horizontal, moving side to side. We then give it a term, right lateral or left lateral. I don't think I'm going to get into that because it's sometimes hard to imagine, and there's better places I can show examples of that. So three primary kinds of fault. What's fun is that a lot of the time with fault lines, you get multiple kinds of motion. So you won't just have a normal fault. There might also be some lateral movement, some side to side movement as well. So you might have a strike slip motion where it's moving up and down like that, but it's also moving side to side. And the last thing is something called a blind thrust. The Northridge quake was a blind thrust. There's a lot of places where the fault line doesn't reach the surface, so we don't necessarily know there's a fault there, but then it ruptures and we realize there was a fault there. So any of those sort of situations where you know it's there, you don't know it's there until it happens. We have a lot of blind thrusts in the LA area where we might not necessarily realize there's a blind fault, but then it wants to go upward. So yeah, okay, let's get into the conversation about why the Santa Monica Mountains exist. Those basic explainer videos were really blurry, and that's because I didn't remember to set up my tripod or anything. I don't have one, so I used my iPad and propped it on my dash. It's a whole thing. Anyway, so history of West LA fault lines and the geology here. So if you look at a map of California's mountain ranges, most of the mountain ranges run they run north-south. And when they're running north-south, they're running like parallel basically to the San Andreas Fault. But you get something very different here in Southern California. And what that is you have a lot of these little mountain ranges that are running east-west. That's pretty unusual to have a lot of mountain ranges running in one direction and then this little chunk of them running in another. And that's because there's a bend in the San Andreas Fault. If I'm feeling really ambitious, I'll edit in a photo to show you where that bend is located. But I left the house late, so we'll see how ambitious I actually am. But there's a bend, and at that bend, what's actually happening is there's a weird little bit of compression happening. I know, buddy. And when that bend occurred, it actually rotated a chunk of the crust. So instead of things, so it rotated a chunk of the crust, and it rotated and caused this compression to happen, while also in a rotational manner. And all of a sudden, what would have been mountain ranges running north-south are running east-west. We call those the transverse ranges. At Hammer Time CA asked a very good question in response to my videos about the different kinds of faults, which the cat, I don't know if it's a guy or girl, so the cat asked if all those faults cause earthquakes, and they do. When it moves, that in and of itself, like theoretically, motion would cause the ground to shake. But also, when you're doing that, you're releasing this huge burst of energy, and that just sends out waves. And those waves are going to be what causes what we feel. Just like if you were sitting on a flat ocean and then a wave came along, it would lift you up. The same thing is basically happening with an earthquake, just with different kinds of motion, different directions of motion. But the size of the fault, the amount of material that is moved, that's what's going to determine how big the earthquake is. So if it's a little small fault, for example, we had an earthquake here in LA the other night about 1:30, and that was a magnitude, I think like a 3.5, and that was a small earthquake. It only lasted for a couple seconds. It was over by La Brea Tar Pits, was not a big quake, didn't shake very long. And so that's going to be informed by the size of the fault that's happening along, as well as the depth, and then also like the length of time since the last rupture. There's a lot of different factors that go into it. So yes, really good question. All faults, when they rupture, cause earthquakes. I was originally not going to do any videos while driving just because I am not really feeling confident about talking while in stop and go traffic. But then I realized I had completely screwed up the schedule of my day. And so instead I'm going to reverse it. And where I was originally going to start out in Hollywood and then end at the ocean, instead I am starting out here at the ocean and then I'm going to work my way over. Just since I'm stopped here, this is a California incline, which goes from up, if you're not from LA, this is what gets you down to the beach. The beach is off to my left. What's happening right here on the right, though, what's kind of cool, you can see the different layers of deposition. You can see, so like that right there, you've got some coarser grained material, you've got some pebbles, you've got different things, and then you move up a little bit and you get fine grained. You can't see the individual, if there's rocks in there, there's nothing. It looks more sort of like what would be mud. And so what you're seeing here is a combination of sea level changes with maybe also uplift. So like as the sea levels change, and then I actually have no idea what I'm talking about ultimately here in terms of like what we're actually seeing. So what you're seeing there as you see different kinds of deposition is you're actually seeing environmental changes happening, that the sea level is rising and falling, or that the rock itself is being uplifted and exposed. So when you have finer grain materials, so when you have like that muddy, silty kind of quality, it is further offshore. You're in deeper water. When you have those pebbles, just like when you're on the shoreline as you're walking into the ocean and you notice that you transition from like a pebbly kind of thing along the beach into, as you get deeper, it starts to get like finer grained and sandier. Same thing is happening in those deposition layers. So you're seeing a much like finer deposition further out, and then you see in the layers that the water, either the water levels dropped and we got into a shoreline sort of situation. I am currently driving around the suburbs of the Pacific Palisades, lost and confused, trying to find the first outcrop that I had hoped to talk about. We'll see how that goes. It's Potrero Canyon, and it was one of the first observed locations of the Santa Monica Fault. It was first mapped in the 1930s. So I'm basically driving around this very developed, very expensive neighborhood, trying to figure out where exactly this thing was that was discovered like 90 years ago. But since we're here and driving around, first off, let's talk about why this is so difficult, why it is so difficult to figure out where fault lines are in a city like Los Angeles. There are a couple different factors, and the biggest factor, obviously, is that we have a lot of things built on top of where we would normally see the faults. So, certain geographical or topographical identifiers, let's say a stream that is interrupted by the fault line. So you have the stream going in one place, and then the fault line runs across it, and the rest of the stream is like 5 feet away. That would be a good indicator that you've got a fault line right there. Okay, I figured out where I'm going. This is actually the destination. Before I get out of the car, I'm not gonna be able to really do much in terms of like show it to you, but I'm just gonna stop here and pop out and point in some stuff. Before we get started with that though, to finish the thought that I was going on before, so yes, if you don't have any sort of overlying development, you could look for direct indicators that there might have been a fault line running through an area. But the downside of the LA in particular is LA is a big basin. And because LA, should I turn this around? I'll turn this around. So LA is a big basin. And we've got the mountains behind us, and all the material washes out into those alluvial plains that I've been talking about the first video where I got everything wrong. So you have all this alluvial, this moving sediment that gets deposited. The LA basin is filled with miles of overlying sediment. So even in the event that you have a fault line, there's a very good chance that you won't be able to see fresh exposures because a lot of the faults aren't active. And then identifying things like sediment beds that then have a fault line running through them aren't exposed because you've got overlying just loose, unconsolidated, gravelly sediments. So those are big difficulties in terms of in LA being able to identify where a fault is. However, because it's also LA and it's very heavily developed, we have a lot of people looking at the land, looking at the ground around us, trying to figure out what's happening so that they can build big buildings. So where we are now is we're right at Pacific Palisades, at the edge of the Pacific Palisades, which, if you're not from LA, is a very nice upscale community on a bluff overlooking the Pacific Ocean. And where we are in particular is what I thought was an actual park you could go into, and it is not, or if it is, I can't figure it out. And this is Potrero Canyon Park. So in the 1930s, as LA was being mapped and explored and developed, I think it was the 1930s, it might have been the 1950s, geologists found this exposure and were able to kind of, from that exposure, determine that yes, this is an area where there's a large fault running through it. Over time, as they started to map more and more eastward from here, they then began to realize that this was maybe a continuous strand of a fault that is very large. Oh, and before I go any further, well, the video is going to run out, so hold on one second. So before I go any further, there are a lot of geologists who have done work in the LA area. There are a lot of geologists But one name that kept coming up over and over and over again was James Dolan at USC, who has done a tremendous amount of work on, in particular, the two fault lines that we're working on, that we're talking about today, the Santa Monica and the Hollywood faults, and the West LA geology in general. So I would not, in all my research, his papers kept coming back up over and over again. I have been quoting him for years, actually, I'll get to that when we get to that place, but he has had a huge impact on the research in this area, and I would not have been able to make these videos if not for the research that he's been doing over at USC. So I try to cite all of my research at the end, and in this case, it really only came from a couple of places, but at truth, a lot of those sources were pulling from papers that he had done. So thank you, Dr. Dole. We're looking through chain link into the Potrero Canyon park, which I thought I could get to, but I can't. So this is a canyon that runs down to the ocean, and this is where the Santa Monica Fault was first mapped as the Potrero Canyon Fault in the 1930s, then remapped in the 1950s, and then it was, like I said, James Dolan who extended it out to connect with the Santa Monica Fault lying eastward of here. So after spending a lot of time trying to figure out where this thing is located, I'm going to start heading back east toward the stuff I actually know about and can get out and kind of sometimes show you. Yeah! Alright, if you've watched other videos that I've done, then this setup with what's behind me is real different than anything else that I've done so far. Mostly I am the only person in the area, and instead I am standing on a street corner on one of the busy intersections during rush hour in LA, which started around 2 o'clock. It's now 4. It'll be going on till about 8, so that'll be fun. So I am at the corner of Wilshire and Bundy. So this is in West Los Angeles, and I'm stopped here because this is where one of the strands of the Santa Monica Fault is. It's kind of a zone as you get through this area. It's going to become a little bit more linear as we go eastward, but right through here there's a few different strands. There's sort of a fault zone where they think that all the faults are connected. But again, a lot of the time this is hard to figure out because you can't just directly look at the fault. You've got the overlying sediments. You have, in this case, a ton of buildings all around. So what ends up happening is that geologists figure out what is underneath the earth from indirect studying, from things called trenches, which I guess is a form of direct studying. You basically dig a trench, then look at the wall in front of you and look for signs of a fault or rupture, things. What's it called? Oh no, gouge, fault gouge, which I had mentioned in the video, the last video series down in the Salton Sea. Fault gouge is when you get that really, really finely ground up rock from the motion of the two plates, or the two sides of the fault grinding against each other. So they use trenching. You also can use water welling. So that's why we're standing here. So they, in 1992, geologists dug a series of wells through this area to figure out where the water table was. And I'm standing on the southwestern corner of Wilshire and Bundy. And here, the water table is about 70 feet below the surface. So then, across the street right there, on the northwestern side of the street, it's about 15 feet below the surface. So that 15 feet to 70 feet is a huge jump. And the reason that's probably happening is because of a fault right through here, which is interrupting the water table and forcing it much higher. So instead of running where it would normally be, you're basically, so it's coming off of the mountains up there, and then all of a sudden it's being pushed upward by a fault to about 15 feet below the surface, and then through here it's back down to that 70 feet. So using water levels along this stretch, you can start to figure out where there might be something impacting the flow of the underground water. So that's a weird thing that now my therapist is like a block and a half, 2 blocks that way, and now I can't help but think of it every single time that I drive by. So yeah. All right, we're going down Barrington, and whee, big drop. Yay! Whee! Oh, that's a fault scar. So that was the fault scarp for the Santa Monica Fault. We're right by University High School on Barrington. I'm at Barrington in Ohio, and I'm turning right because I'm going to try and find a parking spot because while I'm not going to be able to access the thing I want to access, I do want to stand in front of it while I talk about it. I actually didn't mean to find this side, but this is way better than what I thought I was going to find, so that's cool. So I am at the Tongva Sacred Springs, which is on the University High School campus at the corner of Barrington and Ohio. So not too far from where we just were at Wilshire and Bundy. And you can kind of see those little huts behind me. This is a sacred site. It's, of course, was then taken over by LA County, and then they built a school here. But once a month, they do, the first Saturday of every month, they do actually open this up to visitors. There's I think a center on campus that has a little bit of explanation about the cultural history of the area and the significance. And it's one of those, I really got excited about doing this once I realized that I've driven by that. There's a sign that we drove by actually as I was like, wee, because I'm a child. As I was going wee down the hill, we went by a sign that was a California location, like a significant location, a plaque for it, a California historical site. And I've seen that sign dozens and dozens of times growing up in the area, and I never put together that the reason there's a sacred spring here, the reason that there is an upwelling of water here is, again, because we have a fault line running right through here. So this fault, the Santa Monica Fault, again, is pushing up the water table right here, causing it to come to the surface. And as a result, we've got, as you can see through here, there's a lot of, even without the, I would assume even without the landscaping, there'd probably still be like a lot of little trees, probably some cottonwoods that would have been right in this area where the water table was very shallow. So first Saturday of every month, come to University High School to go tour this. I plan on doing that the next time that I happen to have a day off that overlaps with that. So yeah. We're on the back end of the VA property, which is a really big footprint of property here in like the West LA area. The Veterans Administration Hospital and grounds. And James Dolan, who I'd mentioned earlier, did a bunch of trenching on this property actually. And that allowed us to get a better sense of what was happening with the fault all through here. So I don't know why I just waved my hand in front of the camera like that. So a lot of the mapping information that we have comes from research like that he did. If you've ever lived in Los Angeles, then what's behind me right now is probably pretty familiar to you. What's there? That's the Mormon Temple, and it's on Santa Monica Boulevard right here at Overland. I've always heard it described, sorry sir, just doing a video about geology, you know how it is. Yeah, thank you. It was described by Dr. James Dolan as the best manicured or best landscaped fault scarp in the world, because it's this really big, beautifully appointed rolling hillside that is also a major fault scarp because it's the Santa Monica Fault that runs right through here. So again, what we're looking at is, as you've got the hanging wall, this part, and then the footwall down there. Okay, so you got the hanging wall, and they've gone up and down and dropped and gone up, and we're seeing the thrust of the overlying hanging wall here, overriding and pushing and compressing upward. So that's what we're looking at right behind me, and hopefully that's something you think of next time that you're driving on Santa Monica, and then, you know, hopefully it doesn't rupture. Okay, I am at the corner of where Wilshire intersects with Santa Monica. If you are familiar with LA, if you're not, then I am standing in front of the fountain where Cher realized that she loved Josh. Yeah, I love that. Yes, you know, important landmarks. So this is basically where the Santa Monica Fault stops. The Santa Monica Fault runs eastward toward Beverly Hills, but it actually stopped at the Beverly Hills border, we think, and then jumps about 1.5 miles northward. I don't know why I just stepped toward the camera, but northward, and becomes the Hollywood Fault, which then we're going to continue on, and that's going to run along Sunset Boulevard and the base of the Santa Monica Mountains along there. But right here in this stretch is running in kind of a north-south manner is what's called the West Beverly Hills Lineament. And what that is exactly, we aren't totally sure. It was suspected that it was a fault, but there's been a lot of construction in this area in the last like 10 years. And then they're also been doing a lot of research because there's going to be a subway line that runs through here. So they've been doing tons of trenching, cores, like taking core samples, which is when you put a big pipe down and then pull it back up and then look at the layers. Hydro wells, so checking to see what the water levels are. All sorts of different kinds of remote sensing techniques, like basically sending shock waves down and then seeing if we can figure out what the underlying rock is based on that. A lot of different tactics were used in order to see what the geologic makeup of the ground underneath this area in particular is. I had to stop it for a second because my arm was getting tired from holding it up. And anyway, so in the last 10 years, there's been a lot of research done in this area to figure out exactly what's happening underneath the ground level to make sure it's safe to build buildings, because there's limits to how close to an active fault you can build. Figure out what route the metro is going to take as it is dug through the LA area, things like that. And what they determined was that it's not necessarily, they don't think it's a fault, or at least not an active fault. What the West Beverly Hills lineament might be is basically a fold, which is where it should be so theoretically you have the sediment layers like this. You have the different layers of deposition like this, but then they get pushed and then it creates this little like archy thing, a little arch. And so it's a fold in the sediments, and so they think that's what the West Beverly Hills lineament might be. And that might be a compressional feature from all the compression happening in this area. Either way, at this point, we see the Santa Monica Fault stop, and then, like I said, we're going to head north now to Sunset Boulevard for our last few stops to look at a couple things on the Hollywood Fault, which is part of that same little stretch of faulting. I was originally going to get out of the car here. I don't think I am going to now. So up behind the Wonder Park billboard up ahead, we're on Sunset Boulevard. We just got through the Sunset Strip and like all the sunset-y club places, you know, sunset-y club places, all that stuff. So over on the left, we have an exposed fault scarp. So that's going to be like right over there behind the Wonder Park billboard. And that's the exposed fault scarp for the Hollywood Fault, which we're now driving along. And the Hollywood Fault basically follows the trace of the actual Sunset Boulevard. Or I guess Sunset Boulevard follows the trace of the Hollywood Fault from what they've determined through all these extensive building projects that have to happen. You always have to do that work of figuring out what's underneath, because you can't build within like 500 feet of a fault zone. There's a lot of different rules. And so as a result, we get all this great geologic data that's paid for by building companies or in construction projects. So the Santa Monica Hollywood Fault, the Hollywood Fault Sunset runs along it up until Hollywood Boulevard basically starts, at which point the fault kind of curves upward and starts to follow starts to go along what the line of Hollywood Boulevard would be instead. So we're gonna make that turn in a little bit and head toward Hollywood Boulevard. I'm doing this all at rush hour. Oh, if you're ever in LA, eat at Carney's. It's really, really good if you like cheeseburgers. Like In-N-Out's good, In-N-Out's solid, but Carney's has killer fries and they have chili cheeseburgers. So strong recommend on Carney's. But yeah, so we're gonna keep heading east through this rush hour traffic and get to the next stop. So one thing that you might notice as we're driving, I'm about to make this right-hand turn onto Hollywood Boulevard, and we're kind of, like I said, following the trace of the Hollywood Fault, is that when we were driving along the Santa Monica Fault, we weren't really near the Santa Monica Mountains. And now as we're on the Hollywood Fault, we're up on a hillside and we're running along the base of the Santa Monica Mountains right here. You can see the hills up on the left as I make this turn. And I'll try to remember to post a photo so you can get a better sense or a screenshot of a map so you can get a better sense of what I'm talking about if you don't know LA geography. But I don't know why the Santa Monica Fault is so much further away from the base of the Santa Monica Mountains than the Hollywood Fault is. And if anybody out there knows anyone who's doing any studies on this, if you happen to find any papers on it, if you happen to know anything about it, that would be super cool to learn about, because I didn't realize it until I was starting this drive that, yeah, there's a big difference in where the faults are located relative to the major mountain range through here. This is the Capitol Records building over here on my right. That was where Beatles recorded, Dylan, a bunch of famous musicians recorded there, and straight ahead of us we have the Hollywood Fault Scarp again that we're about to drive up. So yeah, right here you've got this really just fantastic exposure that has been paved over, where the Hollywood Fault is again exposed. One of the better examples of it, and that brings us to the end of the trip, because one, it's getting dark, and two, this was as far east as I felt like going today. So yeah, so what have we learned today? We learned that there are two big faults that run through West Los Angeles. They are the Hollywood Fault and the Santa Monica Fault. What else we learned about is that there are different ways of finding out about where there is a fault line. Things like trenching, taking wells, drilling wells to figure out what the water table is, core samples, all sorts of different things. And we also learned that just in general, LA has a bunch of cool geology that we might not know about that's right underfoot. Things I didn't cover, what kind of fault motion is happening through here, because to be really honest, it was a lot of work to do that, and I didn't have my hands free like I thought I was going to be able to talk about what the motion of the movement is. So maybe I'll cover that some other time. But now I'm going to head back west and head toward home, driving parallel to the Hollywood Fault, the Santa Monica Fault, and I will hope that it doesn't rupture in my lifetime, because that would really suck. Okay, thanks for watching, guys. Bye.